All right, geometry. So chapter 12 dives right into circles. So the first section in chapter 12, section 1, talks about tangent lines. Now, again, this idea of tangent is something you've talked about in terms of trigonometry, but it's kind of different. Okay, so again, it's nice you've seen the word before, but it's not really related to like right triangles and sine, cosine, tangent, that kind of fun stuff. All right. So let's talk about what tangent lines are. So this is our picture. So if you see the word tangent, you should be thinking about a line, it could be a segment, it could be a ray, that intersects a circle in exactly one point. So a tangent intersects the circle at exactly one point. So that is point B on this line AB. That point B is called the point of tangency. And again, as I said, you can have tangent rays and tangent segments as well. All right. So we would say that for this picture, we would say that segment AB is tangent to the circle. All right. Now, there's a very important property right here involving tangents and radiuses, or radii. And it says if a line is tangent to a circle, then the line is perpendicular to the radius at the point of tangency. So the big words here are tangent, radius, and perpendicular. So in this picture here, line AB is tangent to circle O at point P. So P is that point of tangency. So that means that where the radius OP touches line AB, those will be right angles because the tangent is perpendicular to the radius. Again, AB is your tangent line in this picture, and OP is a radius of circle O, and they are going to be perpendicular. So maybe you can foresee that with right angles, if I were to connect maybe O to A, you see this right triangle I form. So think of our right triangle ideas from chapter 8, most importantly, Pythagorean theorem. We're probably going to use a lot of that in this section and in future sections in this circles chapter. Again, right triangles, Pythagorean theorem, probably one of the most important things we talk about all year long, so why not revisit it in circles? All right, the second idea here talks about two tangents. If you have two tangent segments that have a common endpoint outside of a circle, so two tangent segments to a circle having a common endpoint outside the circle, then those two segments are congruent. So again, these two tangents with a common endpoint are going to be congruent. That's the idea here. So in this picture here, you have segments BA and BC. A and C are your points of tangency. Segment BA is going to be congruent to segment BC because they are two tangents to the same circle that share a common exterior point. So B is that common endpoint. So B is the common endpoint. And again, it's in the naming of both. All right, so be aware of that. Now down here, a couple other ideas. So in this picture here, you have a circle that is tangent to all three sides of this triangle. We say that the circle is inscribed in the triangle. To have a circle inscribed in you, that means that the circle is tangent to each of your sides. We could also say that the triangle is circumscribed about the circle because, again, that triangle is tangent to all three sides of that triangle are tangent to the circle, right? So be aware of that. We can also do it the other way. We could have that circle circumscribing the triangle as well. All right, but we'll stick with that idea first. Okay. Okay, so all of our problems for this section is in Edulastic. So let's head there and do a couple problems. Okay, so here's the first one. So we have a picture here, and it says that segments ML and MN are tangent to circle O. What is the value of X? Well, X is this angle here at M. So to do this problem, right, this is a quadrilateral, a four-sided figure. Now, a quadrilateral equals 360 degrees. We could use that formula n minus 2 times 180. But if you have it memorized that a triangle is 180 and a quadrilateral is 360, right? You just keep stepping it up in terms of the sum of the interior angles. So the three angles, or the four angles here, are O, N, M, and L. Now, in this picture, OL and ON are radii. Well, we have a theorem that says if you have a line or segment tangent to a radius, then they are perpendicular. Angle L will be a right angle, and angle N will be a right angle. And now we know that this angle is 90. We know that this angle is 90. We have three of the four angles. I think we can find the fourth angle. So I'm going to add the three angles I know. So I'm going to add up, and I'll show you it right here. I'm going to add 90 plus 117, sorry for the lag, plus 117 plus 90. I'm just going to do that right here. So 90 plus 117 plus 90. So the three angles I know add up to 297. So take that number and subtract it from 360. When I do that, I get 63. And that should be the measure of angle X, 63 degrees. Now, there's another hint I want to show you. It's more of a shortcut, all right? So let me erase what I have written here. So if you look at this picture, right? So if these two angles are both 90 degrees, 90 and 90 is 180. Well, if these two angles add up to 180, then what is left over to equal 360? Well, another 180. And that means that this angle and this angle also have to add up to 180. So what is 117 minus, or 180 minus 117? It's 63, which is the answer we put in. Okay, so be aware that you can solve it like that as well. Awesome. All right, so I'm going to stop the video now. I'll do 3 more problems on the next video.